Okay, so it says that the Robin Hood gang planned to carry out robberies in 5 cities over the course of 4 weeks in February 23. The number of robberies every week in each of the 5 cities, as well as the total number of robberies in the 5 cities, must be increasing in the same order. So basically, that Takasaki, Nagasaki, Kawasaki, Hirosaki, and Chigasaki, they will have the total number of robberies in increasing order. Each week, the number of robberies in any city could be 4, 5, 6, or 7. This is all the information that is given to us. Along with that, there is more information. The following facts are also known. And then there are these questions which are there on this data. Of course, now I'll put all the data on one single page. Through that, we'll try to first of all get all the information and then we'll do the questions as well. So I put up all the data on this page. The week wise table is there along with the data which is given to us, and now we'll start filling it up according to that. Let's start. The total number of robberies in any week is a multiple of 3 and it will keep increasing every week during the month. He has already told us the total number of, the number of robberies every week is either 4 or 5 or 6 or 7. So, what can be the total number of robberies in all 5 cities together? So, can I say the minimum number of total robberies can be, if it is 4, 4, 4, 4, 4 in all 5, that is equal to 20, and maximum number of robberies can be 7, 7, 7, 7, 7, that is 35. So, I have minimum 20, maximum 35 robberies which can be there. But he says the number of robberies should be a multiple of 3 and it keeps increasing every week during the month. So they can be 21, 24, 27, 30 and 33 in increasing order. Now I do not know that which one I should write first, second, which all 4 numbers are going to come. But in these 4 weeks, we have to write 4 of these 5 numbers in increasing order. Between 20 and 35, these are the only 5 numbers which are multiples of 3. What next? The total number of robberies in week 3 in every city is more than that in week 1. So in week 3, in every city, it is more than that in week 1. The total number of robberies in week 2 in every city is less than that in week 4, or you can say week 4 is greater than week 2. So for every city, week 3 figures are greater than week 1 and week 4 cities are greater than week 2. Basically, first 2 weeks are smaller than the next 2 weeks. Okay. What next? The next is, in week 1 and week 3, the number of robberies in a city cannot be same for more than 2 cities. In week 1 and in week 3, you cannot have more than 2 same numbers. Now there is a very important point here which is the key point to solve this set. That is, in week 1, the minimum possible total number of robberies can be 21, right? And 21 can be formed in just one way, that is 4 plus 4 plus 4 plus 4 plus 5, right? If there are 21 robberies in week 1, it would only be 4, 4, 4, 4 and 5. That means 4 of the cities will have equal number of robberies. Whereas the question says that no more than 2 cities can have equal number. That means this number cannot be 21. And if this number cannot be 21, that means this number has to be 24. Automatically, this has to be 27, this has to be 30, this has to be 33. There is no other possibility left. There is no other possibility left. I needed 4 multiples of 3 out of these 5. 21 is rejected. So apart from that, these are the only 4 numbers which are left. According to that, I have to write down the total number of robberies as 24, 27, 30 and 33. I'll just remove all of this data from here now for more of rough space that I need. I hope this is clear. Okay. Now the point is, how can I make 24? How can I make 24? So 24 can be made by, I can take 4 and then another 4. 4 plus 4 is 8. After that 16 is left. Now one more thing is there. If every number in week 3 is greater than that of every number in week 1, can I say in week 1 you cannot use 7 at all? I mean, all the robberies in week 1 would be either 4 or 5 or 6. Exactly by the same logic, in week 2 they should be 4 or 5 or 6. Exactly by the same logic in week 3, there should be 5 or 6 or 7. You can't have 4 anywhere because every number of week 3 has to be greater than that of week 1. If I write 4 anywhere, how would that be greater than that something in week 1? And by the same logic, I should have 5, 6 and 7 here as well. So using 4, 5 and 6, how can I make 24? And no more than two numbers can be same. 4 plus 4 is 8. Apart from that, I need 16 more. 16 is made in only one way, that is 5, 5 and 6. Is there any other way through which I can make, and I cannot take more than two numbers same? I think this is the only way through which you can write it, because if I take 4, 5, 5, that makes it 5 plus 5, 10 plus 4, 14. After that, 10 more is left. 10 more cannot be written without writing 6 and 4, because if I write 5 and 5, I will have 4 5s, then that will also be ruled out. So ultimately, the only way through which I can make 24 is 4, 4, 5, 5, 6, such that no number should be repeated more than twice, plus no value is more than 6, because as he has already given us in the question, that every value of week 3 is greater than every value of week 1. I'm sure that you have understood my point here, and through this point now I can say that these numbers are 4, 4, 5, 5, 6. On the first page itself he had given that all these values are in increasing order. Therefore, I would write 4, 4, 5, 5 and 6 over here. Okay. Let's talk about 27 now. How can we make 27? Rather, if I, yes, let's talk about 27. So now in week 2, I have to make 27 using 4, 5 and 6. Now this might have a lot many possibilities at this stage, but let's try to make all of them. Can I make 27 by taking 4, 4? Oh, rather, let's forget about it currently. Why am I saying forget this currently? Because this time there is no condition like that you have to use a number not more than twice. That was about week 1 and week 3. So it's better let's talk about week 3 first. Let's talk about week 3. How can we make 30? And no more than two numbers can be saved. Let's use it. So 30 can be made by using 5, 6 and 7. If I use 5 twice, 5 plus 5 is 10. Apart from that, I need 20 more. So that can be made by 6 plus 7 plus 7. 6 plus 7 plus 7 is 20. Yes. Is there any other way through which I can make it? Let me try. 5 plus 6 is 11. 11, then 19 is left. How can I make 19 without using a 5? I take 6 more and 6 more and then 7. But again, a number cannot be used 3 times. Once again, I can say this is the only possibility through which you can make it. So I will have to write 5, 5, 6, 7 and 7. This is the only way through which this can be made as 30. Only way through which this can be made as 30. What else? If I talk about 33 now, let's talk about 33. How can I make 33? Now the maximum possible sum is 35, which is made by 7, 7, 7, 7, 7. I have to subtract 2. So either I take one number as 5 and the other 4 as 7. Can I take 4 equal numbers now? Yes. It just said about week 1 and week 3 that not more than two numbers can be saved. Or it can be made by 6, 6, 7, 7, 7. But in any case, I can surely say that the last three numbers will be 7, 7 and 7. I hope you are getting my point. Last three numbers are surely 7, 7 and 7. And the top two numbers can be 5 and 7 or 6 and 7. Currently, I don't know about it. And here when I talk about 27, let's try to make 27 now. How can I make 27? Can I take 4 thrice? 4 plus 4 plus 4 is 12. I cannot make 15 by using 5 and 6. Can I take 4 twice? Let me try. 4 plus 4 is 8. After that, what is left is 19. 19 cannot be made by 5 and 6. If I take 4 and 5, that is equal to 9. After 9, I need 18 more. 18 can be made by 6, 6 and 6. Okay, that's one of the possibilities. If I do not use 4 at all, let me take 5 and 5. 5 plus 5 is 10. Then 17 can be formed by 5, 6 and 6. Okay, this is the other possibility. Is there any other possibility? No, I don't see any other possibility. So 27 can be made in these two ways. And once again, when I write them in increasing order, the last two must be 6, right? The last two are definitely going to be 6. The top three are 4, 5, 6 or 5, 5, 5. 4, 5, 6 or 5, 5, 5. Rather, this also is sure as 5. So I can have a 4 and a 6 over here. I can have a 5 and a 5 over here. Similarly, I can have 5 and 7 or 6 and 6 at these two places. Now, if I look at the sum of all these numbers, 6 plus 6, 12 plus 7, 19 plus 7, it is 26. 5 plus 6, 11 plus 7, 18 plus 7, that is 25. This is 5 plus 6, 11 plus 7, 18. With 18, what can I write here? I can write either 5 or 6. But if I take 5 here, that will make the total as 23, whereas it is clearly written the total number of robberies in any city is not a prime number. It cannot be 23. So I cannot write 5 here. If I cannot write 5 here, this case is gone. I have a case of 4, 5, 6, 6, 6. So that this is 24. Now 4 plus 5, 9, 9 plus 5, 14. With 14, I can see either 7 or 6. Now 4 plus 5, 9 plus 5, 14 plus 6 is 20. 14 plus 7 is 21. Both would be okay. 4 plus 4, 8. 8 plus 5 is 13. 8 plus 5 is 13 with 13. Can I take anything? No, I cannot take 6 here. 13 plus 6 will make it 19. So this also is ruled out. I will have a 5 here and a 7 here. So 9 plus 5, 14 plus 7 is 21. 4 plus 4, 8 plus 5, 13 plus 5 is 18. And that completes my table. This is the final solution of this data set. These are the number of robberies according to each week and each city that we have got. Okay, I have put up this table already on my pages now. So let's start doing these questions. The first question: what was the total number of robberies in Kawasaki in the month? Total number of robberies in Kawasaki in the month is equal to 24. So my answer for the first question is 24. Now, what best can be concluded about the number of robberies in Nagasaki during week 2? If I talk about Nagasaki during week 2, it has got 5 robberies. That means exactly 5 is my answer. That is option D. Exactly 5. Which statement is or are necessarily false? Let's look at the table now. There were 5 robberies in Takasaki during week 2. So in Takasaki during week 2, there were 5 robberies. No, this is wrong. First statement is wrong. There were 5 robberies in Hirosaki during week 1. In Hirosaki during week 1, there were 5. Yes, the statement is correct. So my answer is statement 1 only is false. So my answer is option C. Statement A only is false. Now the next question is, on how many instances were 5 robberies planned to be carried out if the robberies in all 5 cities on all 4 weeks are considered? So on all occasions, what all occasions you see 5 robberies are being planned. So 1, 2, 3, 4, 5, 6. There are 6 occasions on which it has been done. So my answer is exactly 6. That is option A. And then this question says, in how many weeks was the same number of robberies planned in Kawasaki and Nagasaki? So Kawasaki and Nagasaki, I have to see when are they equal. Kawasaki and Nagasaki, they are not equal here, they are not equal here, they are not equal here, they are just once equal. So my answer is option D, that is equal to 1. That was one of the sets that we had in LRDI.